What's going on, everybody? It's Mr. Gustin. I'm back in the physics classroom, and today we're talking about the car push lab. So I gave you a challenge in class. I said, all right, we're going to go outside, and I want you to use a few materials to find the mass of my truck experimentally, okay? So we talked about a few different materials, and a few materials that we can use. I think probably the only materials we actually need, unless you feel like you need something else, include these. They include a bathroom scale, which is just your typical bathroom scale, right? You stand on it, you weigh yourself. But this thing can be used any way, and it's something that you can compress. Anytime it's compressed, it measures a force reading on there. Now, it does it in pounds, so we may need to convert over to newtons if you want to use that. I think it also does kilograms, so maybe we can use that conversion factor there as well. But this is our force measurer. We also are given tape measures, meter sticks, stopwatches, those type of tools. So we know what those tools do, and we've used them before. All right, and we're also given my truck outside. And for the example in class, here's the truck. This is going to be my model truck for us here in the classroom because I'm not bringing the truck up in the classroom. So that's that, okay? The background information I asked you to do before we started designing a procedure for finding the mass of the truck, I asked you to do two things. And the first thing I asked you to do was model me the truck moving at a constant velocity. I wanted to see what that looked like. So I need a constant velocity FBD, and I need a constant acceleration FBD. This is what I asked you to do. I said, okay, model me both of these. And so if you missed class and you haven't done these things yet, pause the video and go ahead and model the truck being pushed at a constant velocity and being pushed at a constant acceleration. So pause it, do it now. If you were in class today and just confused, let's look. If I'm going to move at a constant velocity, let's think about what that means conceptually. It means that the acceleration is 0 meters per second squared. If you're moving at a constant acceleration, that means the acceleration is not equal to 0 meters per second squared. Basically what it means is that there's a net force over here of 0, and over here there's a net force that's not 0. So we'll come back to that. Let's model this thing for now. All right, I've got the truck. Obviously, there's the truck. When I push on it, there's going to be a weight, there's a weight force. There's a normal force acting on it. Those are congruent. We're not pushing in the vertical direction. Hopefully, we're just pushing horizontally this whole time. So I'm looking at this, and I got me and 3 of my friends, and we're going to push. There's F push 1. Here's F push 2. And maybe we got some really strong person pushing over here, and this is F push 3. 3 lab partners push on the truck, and they push this way. But again, when they push, they only push at a constant velocity. I mean, obviously, they have to get the truck moving, but once it's moving, once they've overcome the mass of the truck, that stationary frictional force, once they've got it moving, in order to keep it moving, they want to move at constant velocity. So essentially, it's kind of like we have to push to get it moving. So that accelerates it, and then we're going to push with a constant velocity across, okay? And as you see, as I push this thing across the floor, there's obviously a resistive force. There's something holding the truck back. And so that's my friction force. This is the force of friction right here. And that force of friction, because it's moving at a constant velocity, has something really interesting. Let's go ahead and write my F net. This is my F net in the x direction, the direction of motion, the direction we're moving in. So F net x is equal to mass times the acceleration in the x direction. Always write out Newton's second law first. And then we can say there's F push 1, which is working with F push 2, and F push 3 is all working opposite the frictional force. Now, because this thing is moving at a constant velocity, we know that the net force is actually 0, which means when I move some things around, the force of friction in one direction is equal to the sum of all of my push forces. All of these forces are balanced by all of these forces, and that's why we see this constant acceleration. So this is actually a pretty unique scenario where the force of friction can be determined by the push forces if we push it at a constant velocity. That's a pretty cool tool, a pretty sneaky tool we can use because I don't have anything that directly measures friction in this lab. I'm only given the bathroom scale. So log that away. Think about that as you start designing a procedure for this lab. The second scenario we talked about was pushing this thing at a constant acceleration. So it shouldn't be much different, right? I'm going to have the truck. There's still going to be a weight force on the truck. There's still going to be a normal force on the truck. There's still going to be equal because we're not accelerating or pushing this thing up and down. And I'm still going to have 3 forces. Those forces, FP1, FP2, and FP3, maybe the third person's tired now, so they're going to push a little less. But these forces need to be larger than they were before because I'm not going at a constant velocity. Now I'm going to accelerate. So I need a greater net force now to work harder than the frictional force. This frictional force is going to stay the same. Why would it change? It's the same truck. It's the same surfaces. The axles and the tires are the same. This frictional force stays the same, but I'm pushing harder now. And because I'm pushing harder, I am creating an acceleration in the object. Let's look at my F net and the X this time. I mean, based on what I'm seeing here, it looks pretty similar. It looks really similar. So F net X is going to be my push force 1, my push force 2, and my push force number 3, minus the force of friction. But this time, I do have an acceleration. Acceleration isn't 0. And this is where your second procedure or third procedure comes into play. Your job is to use things like a stopwatch and a meter stick to graphically determine the acceleration. I need to find acceleration because I can measure my push forces. I secretly know my frictional force. If I can find acceleration of this truck, I should be able to calculate for the mass of the truck that me and my group mates pushed on. Okay? And that's your challenge here in class. Your challenge is to design 2 procedures and gather the data, analyze the data for acceleration to determine the mass of this truck. All right? Do your best. As always, if you have questions, ask me, throw them in the comments, whatever you have. Until then, see ya!